Okay, everybody. So today we're going to do a new topic, and personally, I find this one kind of fun and not very hard. So it's about something called universal product codes. So identification numbers are everywhere. Most people in the U.S. are identified by our social security numbers, but items like in the grocery store are identified by their universal product codes, or UPCs, as we're going to call them from now on. And those are the barcodes that you have on an item that you scan at the self-checkout so that you don't have to talk to other humans. So there's actually a system to figure out whether UPCs are valid. UPCs. Okay, universal product codes. Marker looks like it's already dying. It is much better. Yeah, much better. Okay. So today we're going to learn about how to determine if a universal product code is valid or not. You can catch, fraudulent items. So UPCs are 12 digits long. The last digit is called a check digit. So as a quick example, we're just going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 5. All right, so there's a UPC code. That's redundant, a UPC. So I'm just going to go ahead and talk through these steps for determining its validity. There's 4 steps, so not too bad. So number 1 is add up every other number starting with the first one. So every other number. So that means you add one, skip one. So starting with the first one. This one, this one, this one, this one, this one, this one. Okay, so you should be adding up 6 numbers. So in my case, 0 plus 2 plus 4 plus 6 plus 8 plus 0. And that adds up to 20. Multiply the sum by 3. Okay, that's easy enough. 20 times 3, 60. Number 3, add up the other digits. So that's all the ones I didn't mark here. 1 plus 3 plus 5 plus 7 plus 9 plus 5. And that is 10, 20, 30. 30. And step 4, add the numbers from steps 2 and 3. So that's this one and this one. So we end up with this number 90, and you're like, okay, cool, 90, what does that mean, right? Well, that tells me that the code is valid, because here's the rule. If the final number ends in a 0, the UPC is valid. If it ends in, I'm about to write into my zone of light reflection here, I see. Nope, that's not going to work. You get the point. If it ends in any other number, it is invalid. Okay? If it ends in any other number, it's invalid. So because we did these steps and got a number that ends in 0, that means this UPC is a valid product code. Okay? So in past years, I always leave these 4 steps up in a corner or something. So I'll try to figure out a way to do that that's still visible on the camera. Let's see. Where's the corner here? How far can I? Okay. So step 1, add every other number starting with first, multiply sum by 3, add the other numbers, add results of steps 2 and 3. And if final result ends in 0, UPC is valid. All right, so just as a counterexample, if we had a UPC 0522004888265. Let's do this again. Add every other number starting with the first. I always like to mark my numbers, otherwise you lose track. I know that's harder virtually. I would advise for this assignment, writing down, like getting a piece of paper, writing a number down, and marking off every other number so that you don't get mixed up, because anybody can get mixed up there. So step 1, 0 plus 2 plus 0 plus 4 plus 8 plus 6. 6 plus 8 is 14 plus 6 is 20. Step 2, multiply by 3. 20 times 3 is 60. Step 3, add the other numbers. 5 plus 2 plus 0 plus 8 plus 2 plus 5. 7, 15, 22. Add them together. 60 plus 22 equals 82. And that is invalid because it ends in 2 and not 0. Okay? So that's determining whether a UPC code is valid or invalid. Now, the last digit of a UPC code is called the check digit. And that's because you can use that digit essentially to check validity or to create validity when you already have the rest of the number. So what we can do is create a valid UPC given all the rest of the numbers by determining what the check digit should be. So, por ejemplo, 381370 09213D. So we start off acting as if we're just checking the validity. We follow the same steps. So adding up every other number. 10, 11, 12, 13, 16. And then we multiply by 3. 16 times 3 is 48. And then we add all the other numbers. 8 plus 3 plus 0 plus 9 plus 1 plus D. I don't know what D is yet, but for now I'm just going to add it in. Okay? And that ends up being, if you add up everything else, 10, 18, 19, 20, 21, 21 plus D. So step 4, just like 4, is adding these two together. So that's 48 plus 21 plus D equals 69 plus D. Yes, giggle all you want. 69 plus D. So essentially, if we want to make this into a valid code, we need to find a value for D that will make this add to a number that ends in 0. Okay? Now remember, this is just one digit. So D has to equal a number from 0 to 9. We can't have D be, 21 or something, right? So just a one-digit number. So what one-digit number brings 69 up to a number that ends in 0? Essentially, what's the next number that ends in 0 after 69? Well, the answer is 70, right? 70 comes after 69. So to get from 69 to 70, that's the next number after 69 that ends in a 0. And I'm sure you could do this without doing the technical algebraic solving, but D equals 1. So essentially what we're saying is, if this is the rest of our product code, then for it to be valid, D has to equal 1, and that will make it a valid product code. Okay? I'm going to do one more example of this. Okay. So step 1, 2, 6 plus 5 plus 3 plus 3 plus 2 plus 1 equals 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Get 20 a lot. Multiply by 3. Add the other numbers, 9 plus 8 plus 6 plus 8 plus 9 plus D equals 17, 23, 31, 40. 60 plus 40 plus D is 100 plus D. So now we're trying to make a value for D that makes 100 be a number that ends in 0, and D has to be a number 0 to 9. So D can't be 10 to make 110. D can't be 20. All of those are two-digit numbers. The fact of the matter is, 100 is already a number that ends in 0. So anytime your number already ends in 0, it can just stay where it is. And obviously, you'll get that D is 0, which is valid, right? There can be zeros in it. We had zeros in earlier ones. And that will be your universal product code that is valid. Okay, we can also create kind of an algebra problem out of missing any other digit, basically, in the code. So, as long as you know what your total is supposed to be, 82740x 756340. And if we're given that our total is 115, in other words, this is not a valid UPC, 0, then we can determine what x is. So again, we start off, same 4 steps. Eight plus 7 plus 0 plus 7 plus 6 plus 4, 10, 24, 32. Times 3 is 96. Add up the other numbers, 2 plus 4 plus x, plus 5 plus 3 plus 0. 6 plus 8 is 14, so that's 14 plus x. 96 plus 14 plus x. So 110. And we know that that is equal to 115 because that's what our final answer is. So after that, we just need to subtract. And we've got that x equals 5. Okay, so we can plug that in there. All right, and we can do the same thing even if x is up here. So x, starting off with x, 86192, 75038, 6. And let's say that our answer is 139. Make sure you can see that. Okay. Cool. So, step 1, mark them. 1. X plus 6 plus 9 plus 7 plus 0 plus 8. So add up everything else, 15, 15, 30. So this is x plus 30. Okay, now the multiplying by 3. We have x plus 30, and we're multiplying this whole thing by 3. Now, you might remember distributive property. This is the only thing that I feel like messes people up is they forget to distribute. And they just write x plus 90, but it's not x plus 90, because distribution means that it's 3 times x plus 90, 3 times 30. So we're just going to leave that there for a sec while we do our other step, other adding. 8 plus 1 plus 2 plus 5 plus 3 plus 6, 10, 16, 17, 18, 19, 25. So now we add them together. 3x plus 90 plus 25 equals 139. We can add these two. That's 115. Minus 5 is 4. 3 minus 1 is 2. Now we got 3x equals 24. What do we do to solve for x? Divide. Get x equals 8. Beautiful stuff. Beautiful. Okay. Yeah, I like it. All right, one more. Get into the mega big leagues here. What if I've got 9, 7, x, 920, 3, 6, 4, 8, 5, and another x. Now the key thing here is that these are both x. In other words, it's not x and y, which means whatever it is, they're going to be the same number. Okay? That's what makes this solvable. If we had 2 different numbers, we wouldn't be able to solve this. But with the same one, we can. So, add every other number starting with the first. That's 9 plus x plus 2 plus 3 plus 4 plus 5. 9, 10, 11, 12, 13, 14, 18, 23 plus x, right? Don't forget we have an x there. Again, 23 plus x is being multiplied by 3. The whole thing is being multiplied by 3. So 23 times 3 is 69. X times 3 is 3x. Add up the rest of the numbers. 7 plus 9 plus 0 plus 6 plus 8 plus x. 16, 22, 30. 30 plus x. So when we add these two together, got 69 plus 3x plus 30 plus x. Oh, I didn't write down our answer here. And we're looking for an answer of 123. So 69 plus 30 is 99. 3x plus x is 4x. Now I can just solve this like a regular algebra problem. Minus 99. 123 minus 99 is 24, just like over there. And divide by 4. And we know that it is 6 both spots. So I like this. It's a fun puzzle. I like UPCs. And next class, we're going to do something similar with determining whether a credit card number is valid. So you never know, if you're in some situation where you have all but one digit of someone's credit card number, maybe you can get the other digit and steal their credit card number. That's what school does for you. Great life lessons. That'll be next time. But this is universal product codes, and these steps are here. I'll also post them probably in the assignment. And it's beautiful stuff, basic algebra.